Hello students, I am going to start now definite integration. So in definite integration, I will be discussing past year IIT JEE advanced level questions. Right, let us go to solve the first question here. The value of the integral e power minus 1 to e square modulus of log x by x into dx is. These are the four options. We'll see the solution for this question. So we have to find its value. So first of all, the given information be denoted by capital I is equal to integral e power minus 1 to e square modulus of log x by x multiplied by dx. Right. For this question, I am going to use the substitution. Put log x is equal to, I would like to use the substitution t here. Then, when you remove the log, x is going to be e power t. Right. Now, the given information is in terms of x. We have decided to change the variable here. We have decided to change the variable. So that means, so here e power minus 1 and e square, they are the limits of x. Now we have to find the limits of t also. So by the way, we must find the value of dx also. Now differentiating with respect to x on both the sides. That means dx is equal to e power t into dt. So I have got a dx value. Next, limits are very important here. So we have to find the upper limit and lower limit here. To find the upper limit here, let us substitute the value of e square in place of x. That means the upper limit will be 2. To find the lower limit, let us go to substitute the lower limit e power minus 1 in place of x. That means logarithm of e power minus 1 will be minus 1. So I have got new limits here which are minus 1 and 2. Now I is going to be, I is equal to integral. So here lower limit is minus 1, upper limit is 2. Modulus of in place of log x t upon in place of x e power t. Here in place of dx, what I am going to write? E power t into dt. So the given information has become like that here. Now e power t modulus is involving here. E power t is always positive. So that means e power t get cancelled here. So that is equal to only modulus of t is left here. Now I am going to break the interval here. So here the interval is minus 1 to 2. I am going to break like that. Minus 1 to 0 plus 0 to 2. So in this interval, modulus of t is going to be minus t multiplied by dt. So in this interval 0 to 2, modulus of t will be t itself multiplied by dt. So normal integration we have to apply, then we will substitute the limits here. So that is equal to, I will write the minus outside. Integral of t is nothing but t square by 2. So limits are here minus 1 to 0 plus here integral of t is t square by 2, but here the limits are 0 to 2. Now that is equal to minus, first to substitute the upper limit. So let me write this 1 by 2 constant outside also. So it is going to be minus 1 by 2. Now only t square is left. Substitute first to upper limit 0 minus lower limit. In place of t minus 1 I have to write, it is going to be plus 1. This part has been completed successfully. Next, plus, already 2 is presenting in the denominator. Let me write 2 outside. Now only what is left here, t square. Let us go to substitute the upper limit. In place of t, upper limit 2, then 2 square will be 4 minus. Let us go to substitute the lower limit. In place of t, 0. That means it becomes 0. We will simplify here. So that is equal to minus 1 by 2 into minus 1 plus 1 by 2. Here plus 1 by 2 into 4 is nothing but 2. So that is nothing but 1 by 2 plus 2 is nothing but 5 by 2. 1 by 2 plus 2 is nothing but 5 by 2. So that means for this question, by taking the support of the substitution, I have got the answer 5 by 2. 5 by 2 is available in option B. So I hope that you have understood this method. Now let us go to discuss the value of integral minus pi to pi cos square x by 1 plus a power x into dx, comma a greater than 0 is. So these are the 4 options here. We'll see the solution for this question. So first of all, let this be denoted by capital I. So capital I is equal to integral minus pi to pi cos square x upon 1 plus a power x into dx. This is the given information. Next, here just observe the limits here. Minus a to a form. So minus a to a means this property we have to recollect. Integral minus a to a f of x into dx is equal to 2 times integral 0 to a f of x dx. If f of x is an even function, if f of x is an even function, integral minus a to a f of x into dx can be 0 if f of x is an odd function. This is my explanation part. That is why I have written here. When we are going to apply this property, this is the question here. This property is applicable only in 2 situations. One is f of x can be even function, other one is f of x can be odd function. So first of all, see, between the integrating symbol and dx, what we have here, that is called integrand. Here cos square x clearly an even function. 1 is clearly an even function because every constant function is considered as an even function. A power x cannot be decided whether it is an even function or odd function. So a power x is neither even nor odd function. So that's why this property cannot be applicable here. Now what we do? So when the limits are minus a to a form, if this property is not applicable, we have another alternate way. We have another property also, which is integral a to b f of x dx is equal to integral a to b f of, in place of x we have to write a plus b minus x. In place of x we have to write a plus b minus x multiplied by dx. So we will take the support of this property. We will take the support of this property. But when you identify the limits, here limits are a to b, but here the limits are minus a to a form. That is the difference only. So whenever this property fails, you have to recollect this property. You have to recollect this property. Now I is equal to, I am going to apply this property directly. Why? The reason is a power x is neither even nor odd function here. So integral minus pi to pi There is no change in the cos square x. That means there is no change in the numerator. Why? In place of x, what I have to write? Minus pi plus pi minus x. That means it is going to be minus x. Because of the even power, the numerator is going to be cos square x only. Denominator is going to be 1 plus a power minus x multiplied by dx. So simple here. What is a value here? Minus pi. What is b value here? Plus pi. So a plus b minus x should be written. So a plus b minus x value what? Minus x. So wherever x is there, we will write minus x. There is no change in the numerator, but only the change is happening in the denominator. Right. Here a power minus x can be written as 1 upon a power x. So that means when I take the LCM, denominator is going to be a power x plus 1, a power x plus 1 upon a power x. So instead of writing in the denominator place here, I have taken this a power x to numerator place. I'll give equation number 1 for the first one and equation number 2 for the second one. I'm going to add these two here, adding 1 and 2. Then left side part is 2i is equal to integral minus pi to pi. There is no change in the limits here. Just while adding the right side parts, both the denominators are same here. That means I have taken the LCM here. Then numerators here, added means added, subtracted means subtracted. While adding the numerators here, what I am going to take? Cos square x I am going to take common here. Cos square x I am going to take common. Then its coefficient 1 plus here cos square x coefficient will be a power x multiplied by dx. Then these two terms get cancelled here. Then finally what is left here? Only the function is left, which is cos square x, So that means, so 2i is equal to integral minus pi to pi cos square x into dx is left only. So cos square x is clearly an even function. So here cos square x is clearly an even function. Here cos square x is even function na. So in this situation we can apply this property. Here clearly cos square x is an even function. So because of even function, what I can apply here, integral minus a to a f of x dx can be written as 2 times 0 to a. So that means integral minus pi to pi can be written as 2 times 0 to pi. Integral minus pi to pi can be written as 2 times 0 to pi into cos square x multiplied by dx. Next, this implies here 2 get cancelled. I is equal to here integral 0 to pi cos square x into dx. So this can be written as 2 times 0 to half of the upper limit. So 2 times 0 to half of the upper limit. What is the half of the upper limit? Pi by 2. What is the function here? Cos square x into dx. So that means again I have taken the support of one more property. So that is equal to 2 times. Now I want to take the support of Wallis formula. What are the limits here? 0 to pi by 2. What is the function here? Cos square x. Right. Let us go to apply the Wallis formula. So here the power is even power. 2 is presenting here. Now I am going to apply the Wallis formula. N minus 1 upon n. Here the power is even power we have. Simply multiplied by pi by 2. So if the power is odd, we will multiply with 1. So here we have even power. Simply I have multiplied with pi by 2. Then apply cancellation here. So that is equal to here 2 get cancelled. So finally what I have got here? Pi by 2. Now let us go to check the options. So pi by 2 is clearly available in option C. So I hope that you have understood this question very well. So two properties I have written, but here one more property I have applied. That property I have kept in my mind only. And one more thing here, I have taken the support of Wallis formula. So generally, if you do not remember the Wallis formula, you can take the support of trigonometry here. In place of cos square x, 1 plus cos 2x by 2 can be written, then integrate. That is another way. But I have taken the support of Wallis formula. So I have got the answer pi by 2. So clearly it is available in option. Now let us go to discuss another question. The value of integral minus pi by 2 to pi by 2 x square plus log of pi minus x by pi plus x multiplied by cos x and dx. Right. We'll see the solution for this question. So first, let this be denoted by capital I. So capital I is equal to integral minus pi by 2 to pi by 2 x square. So directly I am going to multiply with the outside part. What is the outside part here? Cos x. I am going to apply the symbol dx also, plus integral minus pi by 2 to pi by 2. So this term log of pi minus x by pi plus x should be multiplied by cos x into dx. The given information I have written like that. Okay. Now, so it is of the form integral minus a to a. Now, it is of the form integral minus a to a. So, whenever you come across integral minus a to a, just recollect the property. Just recollect the property. So, between the integrating symbol and dx, you have to identify the part which is presenting between the integration symbol and dx is called integrand. Here the integrand is an even function or an odd function you have to identify. So whenever the limits are numerically equal but in opposite signs, that time you have to recheck yourself whether it is an even function or an odd function. Right. So clearly x square is an even function here. X square is an even function. So cos x is the best example for an even function. So when I multiply these two functions here, even into even, that is equal to clearly an even function it is. So completely it an even function. So even function means then I is equal to minus a to a. So integral minus pi by 2 to pi by 2 can be written as 2 times 0 to a. So 2 times 0 to a means 2 times 0 to pi by 2. So write the integrand as it is, x square into cos x multiplied by dx. So this part has completed here. Plus now, so we talk about this integrand here. So cos x is clearly an even function. Cos x is clearly an even function. But log of pi minus x by pi plus x, it is clearly an odd function. So when you multiply odd and even, you are going to get odd into even is equal to clearly odd function it is. So we have the property here, integral minus a to a f of x dx is going to be 0. So that means its integral value 0. Now we have to simplify only this part. So I is equal to, here two functions are multiplying each other. That means by parts method we have to apply. Here two functions are multiplying each other. That means we have to apply by parts method. So simple landmark I want to give. So simple landmark I would like to give. Here x has the even power. That means the degree is 2. So cos x is not having any power. That means the degree is considered as 1. So that means 2 plus 1. So total degree will be 3. I am going to take 3 signs here. This is the landmark I want to give. This is the landmark I would like to give. So plus minus. So you just write plus symbol first. So out of these two functions, one should be integrating part, other should be differentiating part. So what is the differentiating part here? X square. Next, write the neighbor of cos x. Who is the neighbor of cos x? You know, sin x. Next sign is plus. Next, x square derivative 2x, neighbor of sin x, cos x. Next sign is minus 2x derivative 2, neighbor of cos x, sin x. So in a single line, I have done the integration here. So after that, what we have to do? We have to apply the limits here. So outside 2 is there. What are the limits here? 0 to pi by 2. So once again I will explain. So first, here the limits are 0 to pi by 2. So totally here the degree I have calculated here. The degree is 3 here clearly. So that's why I have taken 3 signs, plus, plus, minus, plus, plus, minus. So it is going to be differentiating part dp, then it will be ip, integrating part. One is ip, other one dp. So first of all I have taken the sign here, positive sign. So first I have written differentiating part x square, then neighbor of cos x is sin x. Next, positive sign, second sign is positive sign, x square derivative 2x. Next, sin x neighbor cos x. Next sign is negative 2x derivative 2 cos x neighbor sin x. Like that I have finished in a single line. So between the limits 0 to pi by 2 we have to find the value. So that is equal to 2 times. So first I would like to apply upper limit. In place of x, pi by 2 should be written. So here this value, first term is going to be pi square by 4. In place of x pi by 2, sin pi by 2 1. Next here cos pi by 2 0, leave it. Next sin pi by 2 1. So already minus 2 is there. That's why when I substitute the upper limit, I got pi square by 4 minus 2. Next, minus, we have to substitute the lower limit here. Wherever x is there, we have to write lower limit 0. So here x is presenting sin 0 0. Here x value 0. So 0 into 0, leave it 0. Here x value 0, leave it. Here x value 0. So that means sin 0 0. Totally when I substitute the lower limit, I am getting 0. So I am going to simplify this one. That is equal to, when I multiply with 2, first term is going to be pi square by 2 minus, here 2 2s are 4. So this is the value I have got for this question. So pi square by 2 minus 4. So clearly it is available in option B. So I hope that you have understood this question very well. Now let us go to discuss another question. The value of integral root of log 2 to root of log 3. X into sin x square upon sin x square root plus sin of log 6 minus x square into dx is. So these are the 4 options. So we'll see the solution for this question. So first of all, let this be denoted by capital I. So capital I is equal to integral. Here the lower limit is root of log 2 and the upper limit is root of log 3. So what is the integrand here? Sin x square upon sin x square plus sin of log 6 minus x square. So this x I am going to write with dx. So between the integrating symbol and dx, what we have, that is called integrand. So this is completely integrand including x. Now here I would like to use the substitution. Put x square is equal to t. Put x square is equal to t. Then we will do the differentiation on both the sides. X square derivative 2x into dx, that is equal to dt on the right side. Then x dx value I can write directly dt by 2 by skipping this step. Then x into dx value is nothing but dt by 2. I can write directly by skipping this step. Now, these are the limits of x. We need to find the limits of t here. So, t is equal to, we'll see the upper limit here and lower limit here. Here t is equal to, in place of x, substitute the upper limit. So, upper limit is going to be log 3. Next, to get the lower limit, substitute root of log 2 in place of x. That means I have got log 2 as a lower limit here. So, these are the limits of t here. Now, let us go to substitute. I is equal to, what is the lower limit I have got? Log 2. And the upper limit is log 3. Now, wherever x square is there, t should be written. Wherever x square is there, t should be written. In place of x square, what I have to write? Only t. In place of x into dx, what I am going to write here? dt by 2. So, dt as it is I will write, 1 by 2 I will write outside. So, I hope that you have understood this step very clearly. Now, I would like to take the support of this property here. Here I have noticed log 6. Here I have noticed log 6. Here, when I add these two limits, I am getting log 6. Then I got the idea to apply this property. What is the property here? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x into dx. This property suppose I would like to take. Now, I is equal to 1 by 2 outside as it is, integral log 2 to log 3. In place of t, what I have to write, in place of x here, a plus b minus x should be written. So, in a similar way, in place of t, what I have to write? Lower limit 2 plus upper limit 2 minus t. That means log 2 plus log 3 minus t. So, directly I am going to write sin of, in place of t I have to write log 6 minus t upon, again sin of, in place of t log 6 minus t plus sin of, see here, in place of t what we have to write? Log 6 minus t. Okay, then log 6 get cancelled. Finally, what is left? Only t is left here, multiplied by dt. If it is equation number 1, it is going to be equation number 2. Now, I am going to add both the equations. So, from here, left side part, 2i is equal to, here I plus I is equal to 2i. While adding, what is the common part? 1 by 2 is common in both. Now, integral and the limits are also common here. Lower limit is log 2, upper limit is log 3. Next, here what I have noticed here, both the denominators are same here. Both the denominators are same. That means numerators must be added here. So, when I add the numerators, I am getting the value of denominator. So, that means here both numerator and denominator are same. That means when I apply cancellation, what is left to here? 1 multiplied by dt. So, finally, this implies 2I is equal to 1 by 2 times integral of 1 t. After that we have to apply limits. What is the lower limit here? Log 2. Upper limit here log 3. So finally here we need I value only. So finally I is equal to 1 by 4 times, first substitute upper limit log 3 minus lower limit log 2. So log 3 minus log 2 is nothing but, so log 3 minus log 2 is nothing but log of 3 by 2. So that means I have got the answer for this question 1 by 4 times log of 3 by 2. So clearly which is available in first option. I hope that you have understood this.